Hello students, before we start our chapter, I would like to request you all to watch our introductory 2 videos given by me so that you will be clear about the 3-step strategy to do DHAMAKA in physics exams. We have given the videos in the description box, or you can just click on our videos displayed at the end of this video for either introductory 2 videos or the next videos. Okay then, let's enjoy physics by Mr. Patel, who has a long, profound experience of 29 years of teaching physics in Sainik School, Balachan.
Example 6.9, two concentric circular coils, one of small radius R1 and the other of large radius R2, such that R1 is very less than R2, are placed coaxially with centers coinciding. Obtain the mutual inductance. Let I2 be the current through the outer circular coil, that is a bigger coil. See, this one is bigger. Current flowing through it is, say, I2. So, I2 be the current through the outer coil, circular coil. The magnetic field B2 at the center of the coil, say B2, then B2 is equal to, we know that the magnetic field at the center of this coil is, say, B2. From the Biot-Savart law, we know that B2 is equal to mu 0 I2 upon 2R. R is the radius. Here it is small r, R2, so R2. R2 is the radius of the bigger one. So, B2 is equal to mu 0 I2 upon 2 R2. The flux linked with the smaller coil is, say, phi 1. There is a smaller coil of radius, their center is the same, of radius R1. R1 is very less than R2. So, inner coil is very small, radius is very small. So, magnetic field B2 almost considered to be the same in this area. So, flux leakage will be also almost same. So, flux leakage phi 1 with the coil, smaller coil, say the flux leakage is phi 1. Due to the magnetic field, there will be a flux. So, flux leakage with this coil is almost the phi 1 is equal to B2 into area of the smaller coil. Area A1 is equal to pi R1 square. Therefore, flux phi 1 is equal to mu 0 I2 into area, this is the magnetic field B2 upon 2 R2 into pi R1 square. But phi 1 is equal to, the flux phi 1 is directly proportional to the current in the bigger coil. So, phi 1 is directly proportional to I2, that is, therefore, phi 1 is equal to some constant M12 into I2. We have already studied this. The M12 is the mutual induction of a coil, smaller coil, one coil with respect to the second, that is bigger coil, smaller coil with respect to the bigger coil, or one with respect to 2, we can say. So, M12 is equal to mu 0 pi R1 square upon 2 R2. And M12 is equal to M21. We know that mutual induction is the same, whether it is with respect to 1 or 2. That is M12, that is mutual induction of coil, smaller coil 1 with respect to the bigger coil, that is 2, is equal to the mutual induction of bigger coil 2 with respect to the first also. And that is equal to same mu 0 pi R1 square upon 2 R2. Next, the mutual induction. Let us see this phenomena. It is the phenomena of production of induced EMF in one coil due to the change of the current in the other coil. We know that induced EMF is produced or generated in the coil itself or nearby coil whenever there is a change in the magnetic flux linked with the coil, according to Faraday's first law. So we consider this is one coil, let us call it primary coil P. This is second coil, you can say 1 on 2 also, this is secondary coil symbolized by S. This is a circuit diagram, the battery, key, rheostat. The current is passed, when key is pressed, the circuit is completed and current will grow in this circuit, will increase from 0 to maximum. Correct. So there will be magnetic field will also will increase and flux also will go on increasing. So there will be a change in the flux. This flux will link with another coil S. So here we are passing the current in the one coil, and in the second coil it induces the current due to the change in the flux. We know that rate of change of flux is equal to the induced EMF will be generated, and hence current. Current is due to the EMF. So first EMF is induced, and due to the EMF current is flowing. Galvanometer shows the deflection. But if we keep on pressing the key, there won't be any induced current. Why? Because the maximum current reaches after a short time to its maximum value. Then after there is no change in the current. So there is no, it should be a varying current. When there is a varying current, there will be a varying magnetic field and varying flux. So that will only induce the EMF in the another coil or coil itself. So there should be varying current. So current grows from 0 to maximum. So if we make the circuit, current grows. If we break the circuit, current decays like that. The flux phi linked with the S. The flux phi linked with the S is directly proportional to current in this. Flux linked with this is proportional to the current in the primary. So flux phi is directly proportional to I. Current in the I is the current in the coil P, that is primary coil. So flux linked with the S is equal to some constant M into I. M is the mutual inductance. The phenomena is called induction, electromagnetic induction, that or mutual induction, and the M is called the inductance or coefficient of mutual induction. Correct? So phi is equal to Mi. If I is 1, then M will be equal to phi. So mutual inductance can be defined as the flux linkage with the S coil, one coil, when current changes in the current in the other coil is 1 ampere. Current flowing is 1 ampere in the second coil. When 1 ampere current flows in the primary, the flux linkage with the S is equal to M. This is one definition. Again, according to Faraday's law, take the derivatives of this equation. d phi by dt is equal to m constant di by dt. So d phi by dt is equal to minus m di by dt. Minus sign, that is according to Lenz's law, because induced EMF is such that it opposes a very cause producing it. So from 1, if I is 1, already we have studied, correct? The second one. So again we can define the M. M is equal to, if di by dt is 1, that is rate of change of current. Current changes at a rate of 1 ampere per second in the primary coil. Then induced EMF generated in the S is equal to the M. The unit current pass through it, that is, you can define mutual induction of two coils is equal to the magnetic flux linked with the one coil when a unit current passes through the other coil. When unit current passes through the other coil, this one, and whatever flux is linked with this circuit, S, that is, or coil or circuit. Again, from the equation second, we can say, again from this equation second, we can say M is equal to E upon di by dt. Correct? So if di by dt is 1, then induced EMF is equal to M. So it is equal to the induced EMF when current changes the rate of 1 ampere per second. Correct? So when current changes in the 1 ampere per second in the another coil, correct? This is in this P coil. Then induced EMF generated in the S coil, that is equal to the M. Thus mutual induction is defined as the induced EMF E produced in one coil, that is S coil, correct? When the current in the second coil, that is primary, changes at the rate of 1 ampere per second. Its unit is Henry, correct, or Weber per ampere. Phi M is equal to phi upon I. I is current in ampere, phi is in Weber. So Weber per ampere or Henry. Or you can say M is equal to E volt upon this dI by dt, that is ampere per second. So volt into second take up into ampere minus 1. Now next topic, self-induction phenomenon. It is a phenomenon of production of induced EMF in a coil itself when a changing or varying current passes through it. When varying current passes through the coil itself, there is induced EMF and hence induced current, which opposes according to Lenz's law. So battery current is flowing, we can say this is clockwise, this is in the anti-clockwise. So I is induced current due to the induced EMF. So when the key is pressed, current will grow from 0 to maximum, and during this growth there will be an induced EMF and hence current, because there is a varying current passing through the coil, and that will induce an EMF according to Faraday's laws. And varying current will cause a varying magnetic field and varying flux. So whenever there is a change in the magnetic flux linked with the coil itself, induced EMF is generated. So flux phi is directly proportional to current I. So phi is equal to Li. L is a constant of proportionality called the self-inductance or coefficient of self-induction. When I is 1, as before we have seen, phi is equal to L. So definition of L, that is inductance, is defined as the magnetic flux linked with the coil when the unit current flows in it through it. So when current is unit 1 ampere, then flux phi is equal to L. So it is magnetically equal to the flux phi linked with the circuit itself when unit current flows through it. Again, as we have seen in the mutual induction, phi is equal to, according to Faraday's second law, d phi by dt, that is minus L di by dt. So when current changes at the rate of 1 ampere per second, the magnitude of the induced EMF is equal to the L. It is not 1 Henry, remember, as in the case of the mutual induction and self-induction. If this current is changing at the rate of 1 ampere per second, and if induced EMF is 3 volt, then it will be L will be equal to 3 Henry. If it is 5 volt, then L will be equal to 5 Henry, and so on. But if it induces a 1 volt, then L will be equal to also 1. If current changes at the rate of 1 ampere per second, and induced EMF produced in the coil itself is also 1 volt, then L will be equal to 1. This is 1, this is 1, so L will be equal to 1. So if di by dt is equal to 1 ampere per second, then E is equal to L. Then you try to define yourself. Barabar? The self-inductance of a coil is defined as the magnitude of the induced EMF produced in the coil itself when current changes at the rate of 1 ampere per second in the coil itself. Again, if E is equal, that is equal to, or L is equal to E upon di by dt. L is equal to E di by dt. So E is in volt, di by dt is ampere per second, correct? So if E is 1 and di by dt is also 1 ampere per second, then this will also be 1, then it is 1 Henry. So self-induction of a coil is said to be 1 Henry if current change in the coil at the rate of 1 ampere per second produces or generates the EMF. Dimensions of self-inductance. We know phi is equal to L into I. L is the self-inductance and I is the current flowing through the coil. So L is equal to phi upon I, that is Weber per ampere, or phi is equal to another unit B into A upon I. That is the same unit in different form. Phi is equal to magnetic field into area. We know the magnetic field is given by the Lorentz force Q V cross B. Barabar? So the B is equal to that is VB sin theta. If angle is 90, then QV, F upon QV. So B is equal to F upon QV, that is VB, QVB. So B is equal to F upon QV or F upon QV sin theta into A by I, correct? A is the area upon I is the current. So L is equal to, put the value of this, that is B is equal to, what is the dimension of B? F, that is F kg meter per second square, that is mLt minus 2, dimensions of the force. Area, dimension of the area is L square. Charge, coulomb, velocity, meter per second, the L by T minus 1, and I, current in ampere. So L cut, and coulomb per second, that is ampere. So ampere into ampere, ampere square. So m L square T minus 2, ampere minus 2, mL to T minus 2, A minus 2. Next topic, self-inductance of a long solenoid. Let L, R and N be the length, radius and the number of turns respectively of a long solenoid. Long solenoid, that is length is very greater than the radius of the solenoid. The field inside the solenoid is given by the B is equal to, we know that field inside the solenoid is given by the equation B is equal to mu 0 Ni. N is the number of turns per unit length. If it is a L length and number of turns total is capital N, then small n, number of turns per unit length is N by capital N by L, we know. So B is equal to mu 0 Ni. The flux linked with the each turn will be magnetic field B into area of the turn, that is pi r square. So mu 0 Ni A, that is the flux. This is the B field and this is the flux phi, correct? We can say this is a flux, that is, it is already written, flux phi linked with the each turn, or we can say phi dash also, phi. Now total flux phi linked with the whole solenoid, entire solenoid is say phi, then phi is equal to phi dash into N, capital N or NL. So total number of turns. This is the flux linked with the one single turn. So for the NL turns, the total turns is NL, that is equal to mu 0 NIA into NL, that is equal to mu 0 N square L A I. But phi is equal to Li, so Li is equal to this one, correct? Flux is equal to Li, or L is equal to mu 0 N square A upon L, that is N is equal to NL. So we have introduced the value of capital N, small n in the terms of capital N. So N square is equal to N square L square. So this N square, that is divided by N. So mu 0 N square A upon L. Suppose if coil is wound over the material of high permittivity, relative magnetic permittivity, that is mu r, for an example soft iron, it increases the magnetic field 1000 times, that is L is that, correct? The permittivity mu r, then the L will be equal to mu r relative permittivity into mu 0 permittivity in the vacuum into N square L A, this same, or is equal to in this term mu r mu 0 and square capital N square A upon L. Thus the L, the mutual self inductance of a coil is directly proportional to N square. It is directly proportional to the area of the solenoid turns, or it depends upon the core, that is the material of having the high magnetic permittivity.